Okie dokie. We'll share screen. Start PowerPoint. It's backwards. There we go. What if I do this? There we go. Swapping. Okay, chapter 9 is kind of exciting. It's kind of the meat and potatoes of civil drafting. It's about the plot plan, right? The site plan, site, plot, whatever, right? The site is the area, the plot, well, is also the area. So those are somewhat interchangeable. We also use the word plan as analogous. Well, it is the top view. So in mechanical drawings, we have, top, front, side, right? And construction and architectural types of things, they have like a floor plan. We have a site plan. Plan view is just an overhead view or a top view, yeah? And then the other two views, projections, right, are considered section view and profile views. So we'll look at those in a civil context later, but right now we're going to talk about plan view. So cool. That takes care of it. Oh, and then we'll talk about legal descriptions, like how do you describe in words the boundaries of whatever you're doing. Like if you're going to put a building on a piece of land, you want to be able to control that land for its runoff and everything else, and so legally you have to be able to control that, so other people don't build stuff on it too or whatever, right? And that gets messy, I guess. And so that's why we have property boundaries and stuff. So oops, didn't see someone. Sorry, Vanessa, just getting on there. All right, that's good for terms, I guess. Some other terms that are used in describing properties or boundaries are, this was an old but still used way of doing it. And in the US, you find this more commonly in the eastern part of the United States. And that's called the meets and bounds system. And that basically describes property using measurements and existing or physical boundaries like rivers and cliffs and mountains and trees even and stuff. And also streets, not just natural boundaries, but man-made as well. So we have these measures and boundaries, right? So meets and bounds. Here's an example of a legal description describing in a meets and bounds kind of way this property shown in the figure here. I think this is actually in the book as well somewhere, maybe, or well, anyway, actually got this off of a different website. So did the book, I guess, or whatever. Anyway, beginning, so you always have some sort of beginning, right? So you start somewhere, and that's usually tied into some known location, like a benchmark, like some previous surveyed location. So you can reference property in regards to a common reference. Otherwise, it's anarchy, and I understand that argument too. But anyway, beginning at a stake in the ground, which is the northwesterly corner of said parcel of that land. So that's a way to describe, where that is and how you're just starting. So thence, so at that point, you continue, right? So that's the word thence, a bearing, right? North 89 degrees east, and for a distance. So there you go. There's a measure. Thence, so right from there, you make a turn, and at this point, thence, right? South 45 degrees west is a distance of 5,500 feet. So that would put you, here, I have a little marker. use a red marker. So basically, that first line comes across here for 600 feet, and then thence southwest, south 45 degrees west, 500 feet, thence north 250 feet, well, north the bearing, and then 250 feet. So 2 degrees west at that 250 feet, which is the center or the intersection of, you know, these other meets, right? These other boundaries, I mean, and yep, thence northwesterly to the point of beginning. And usually you might even have a bearing there too to help with that. But there you go. So that is a legal description of that piece of that shape, that property boundary. Afterwards, it became a little more cumbersome to use that system. So as the population increased and people moved westward, the government commissioned a bunch of surveyors, which is a good job for them, right? Gave them a livelihood and whatnot, to measure in a gridded fashion, like a rectangular grid for coordinates, right? So you could locate stuff based on a rectangular coordinate system rather than just these odd boundaries. And so if you look at a map of the United States, like the counties and the states even, you'll see in the east that they're very irregular, like they usually follow a river or something, and that still happens, you know, in the west. But in the west, the states even are much more rectangular. You'll see, you know, like Colorado, that's like a rectangle. Wyoming, that's a rectangle. New Mexico's very rectangular. It has some nubs on it in the south and on the east part, right? Arizona, very rectangular. Nevada has a inclined edge on it. But if you think about it, Kansas, even Oklahoma, as far east as Oklahoma and stuff, that's where you're getting closer to the Mississippi, but it's still very rectangular. So it's interesting anyway, kind of a historical kind of thing. Anyway, so it uses latitudes and longitudes, right? Meridians and latitudes or parallels for as baselines, as references to make these rectangular grids. Okay, this is how it works. As you go on, they would measure out these rectangles and stuff, but then they got so far away from the beginning, like the origin of their coordinate system, if you will, right? They're just trying to grid the thing out, and so they had to start a new one. And so that's what you're looking at here. Is, well, here's the New Mexico baseline. That's the line of latitude, sorry, that it's starting on. So everything north of that is a north, everything south of that is a south, and then you have your principal meridian, which actually goes into, there's a little jog in there, but that goes into, so that's the prime, or what do they call that? The New Mexico principal meridian, right? So that is the origin of the coordinate system for New Mexico, right? So we'll see how that kind of plays out. But then you also have an Oklahoma one, a Cimarron, Gila, and Salt River principal meridian, right? Meridians are lines of longitude, okay? And your baselines are lines of latitude, or your parallels there. So there's the Gila River in Salt Lake. There's the Navajo one. Can't zoom in on this, but you'll notice that this doesn't really exist in the east, but even in the south and a few places even east of the Mississippi, you'll see that. But like I was saying, look at Kentucky and Virginia and West Virginia and stuff. All those boundaries are kind of based on rivers and stuff. Whereas the further you go west, you're looking much, much more rectangular. I'm not sure what happened with Idaho, but that could be a river too, for all I know. And then, so you have you know, much more square and rectangular looking states and counties for that matter. So yeah, you look at the counties in like Virginia or Kentucky or something, all these guys over here, it's crazy. They're very irregular. So it was great for the bootleggers because, you know, county boundary could change and you could be in one county in 5 minutes and then back into the other county still going north or something. Anyway, back to this. So the surveyors would go out there with their chains, right? Their chains were 66 feet long, so every 80 chains was a mile. So they just chain it off, count 80 chains, put a marker, right? You'll still see those markers in the ground every so often. So I have some pictures of them. Okay, so how did they, you know, every 6 miles, every square that was 6 miles by 6 miles was considered a township, okay? And that square is called a township, but also you count how many townships you are north or south of that baseline, right? And you also, so that's a north-south measure. A township is a square, but it's also a measure of how many squares you are north or south. A range describes how many townships you are east or west. So that's a range is every 6 miles. One range is a 6 mile distance from, so range 1 is 1 mile, well, it has to be east or west. So one range west is 1 6 mile square west of the principal meridian of that coordinate system. So we'll get it, we'll see how it, when we put it all together here. So, well, here we go. So like we said, we had a baseline and a principal meridian, and we have townships. So if this highlighted one in blue would be 2 townships north of that baseline, right? So that's township 2 north. And it's also 2 ranges west of that principal meridian in red there. So it's range 2 west. Is that right? And likewise, each 6 mile square, that's a lot. You know, most people today don't own 6 miles of square of, that's actually a lot. So they broke those down into 1 mile squares. There's 36 of them, and they're numbered both astronomically, which is a nice Scrabble word. Not really, because that's more than 7 letters, but it's a nice word to make you sound smart. But that just means as the ox wanders, right? So it goes back and forth. I call it serpentining. So it goes starts at the top left and just comes around, and it both astronomically. You ever heard of an oxbow lake? Right? Well, it's where a river, it just winds back and forth like this, right? And then at some point, yeah, we can Google it. Here, I'm going to Google it real quick. There we go. Oh, nice pictures right here, images. See, when a river winds around just because it's following the flow of the land or whatever, right? At some point, it actually, see how this guy right here? We'll open that up in a new tab. Okay, see how this river? It's actually, at some point, it'll erode away this land and it'll cut itself off, and then it'll just continue on, right? So the river goes on and it leaves, you can even see it leaving other oxbows around there. This is a nice picture of it. So that ends up being called an oxbow lake because the river winds around like an ox wandering, and once it cuts off, it becomes a lake-ish kind of thing, and the river keeps going. So it leaves these little strips of lakes around. So ox, both estrodonic, is just as the ox wanders. See, you came here thinking you weren't going to learn anything, right? Just kidding. Okay, back to where we are here. Okay, so that's how every little 1 mile square is called a section, right? There are 36 sections in each township. And just so you know, 1 square mile is 640 acres by definition. And there's that bostraphodonically, there's that word there, so you can memorize that and amaze your friends at parties. Anyhow, and we already explained that. So each section is also broken down because a lot of people don't own a square mile of land either, right? I mean, the house that I live in it's not even an acre. It's not even, and 1 square mile is 640 acres. So you got to break those down too, right? So we're going to get to that. So here's how a section is broken down into halves and quarters of quarters and halves of quarters. You can break it down any way you want almost, right? So the first major breakdown of a section is in quarters or halves actually. But in this case, we have this guy right here. Pen. Okay, this is the northeast quarter, right, of this section. However, let's see. This guy right here, this quarter, this 16th of a section is, well, originally it's in the northwest quarter, but it's the southwest quarter of that northwest quarter. See how they break it down like that? So it's actually very efficient to, cut it down to half and then half it again and half it again. You can really break it down really small. What was that? What's the allegory of the pauper playing the king or something like that? You ever heard that one? Where a kid's playing a king a game of chess, right? And they have a bet or something like that, and the boy bets the king. He says, okay, if I win, why don't you put 1 grain of sand on the first square of my chessboard, 2 grains of sand on the second one, 4 on the third one, 5, 8, just keep doubling it on each square. And the king thought, okay. And so, but what the king didn't realize is that at a chessboard is 8 by 8, right? I think. Yeah. So that's get the old calculator out. He didn't realize that calculator. There you go. That's basically the last square, not even considering the one before it. Just do this, 2 raised to the 64th power, right? Because it's just doubling it every time. So 2 to the 3rd, 2 to the 4th, 2 to the 5th, 2 to the 64th, right? So that's that many grains of sand. He would have owned his kingdom. so, yeah, that many grains of sand, right? I mean, that's way more than a trillion. What is that? That's you got 709 million. So 73 billion, 744 trillion, 446 quadrillion, 18, I don't even know what that number, 18 tetrillion or pentillion. I don't even know what that is. Quintillion? I think it's quintillion. 18 quintillion grains of sand, which is like probably more than his kingdom, more than the earth, probably. Anyway, okay, I digress. So back to the fun stuff here. Let's switch that. So, in other words, this is a very efficient way to break down the sizes of the properties. So most people own, like, okay, so if you look at this whole square, 640 acres, right? A quarter of that is 160 acres. A quarter of that is 40 acres. And a lot of people own 40 acres of land and parts of that. So you can break that down into 10 acres, and a quarter of that, 2.5 acre lots. A lot of lots are an acre and a quarter, and so forth. But anyway, after that, you can, that's still very big, right? I mean, you can put lots of houses on that. So after you break it down, but a subdivision could take up like 40 acres easy, right? Or more, right? So here's after you get down to that, you describe the subdivision, like if you're doing like residential stuff, or even zoning, like city zoning and stuff, you do it this way, right? So your property descriptions are referenced by a lot and a block, right? So we have a house which is on lot number 19 on block 9 of the Cherry Hills subdivision in Farmington, New Mexico, right? That's how it's listed on the records of the, what do you call it? The guys in the county parcel division, what do they call it? If you want to go get your land records, like your property records, you go to the county assessor. I don't know. Anyway, they also take the taxes, right? That's how they tax you. Okay, but putting it all together now, so I just described this house that we have that's on lot number 19 in block 9, lot number 19 of block 9 in the city of Farmington, in the southwest quarter of the northwest quarter of section 1, township 29, range 13 west of the New Mexico principal meridian. And then you can describe it, you know, the San Juan County in New Mexico, right? That can tell you exactly which property that is. That's called a legal description. That's part of the legal description. And then they would go into describing the directions and distances of that actual lot. As it says down in the bottom here, right? It says described as follows. And then it would describe, you know, starting at some point of beginning and going this far, this far, this far. And that now it comes down to, you know, how do you draw something like that? How do you, you know, you would draw it from that, or when you draw it, you describe it with those meets and bounds, right? Those measures and those and where it is based on those. Oh, I didn't mention, but all that rectangular system, that's called the public land survey system. So when the government hired all those surveyors to go out there and grid it out and measure it off and record it, that was the public land, that became the public land survey system. So a typical plot plan will may have any number of these elements to them: a legal description, the property lines with dimensions, right? The north arrow, existing and proposed roads, right? So if you're building a new subdivision, you might be drawing the actual roads in there, like where the roads are going to go and where the properties are going to go, as far as construction work goes. And then there's concrete work, structures, wells, power lines, other infrastructure, sewage. There's soil test holes, right? You drill down and you test the soil. Make sure you're not over a landfill and things like that, or that the soil can withstand the construction, and so forth and so on. Drainage, right? You can't be flooding, right? So you got to be able to mitigate the water flowing through when it rains and whatnot. That deals with elevations. That's why we did all that work on the contour lines and stuff. That's used to figure your elevations and to figure the slope of the ground and where everything should go. And then we also have another chapter later on where it goes into the earthwork. Like, how do you actually flatten something out? You use that contour map, you use that elevation data to figure out how much earth you're going to have to move, and that's also used in the figuring out the estimate for it. So. Okay, so we also put the scale of the map, the total acreage of the property, other water features in it, easements, the basic ideas of the construction, like if it's a residence, how many bedrooms, garage, concrete work, stuff. Okay. But so there's a lot of stuff coming into the house, like water, electricity, internet, Got to have those three things at least, right? But there's also something coming out of the house, and that's the sewage, right? So there's three basic ways to handle the waste products coming out of the house, right? Well, besides just the garbage collection, right? You either take it to the dump, or the dump comes to you, right, with the big truck. So it depends on where you live. We've lived in Kirtland where we had to take our trash to the dump. And now we live in Farmington where the dump comes to you, or the truck comes and picks it up and takes it to the dump, in other words. So, however, the water-based waste goes down your drain, right? And so that ends up in the sewer. Or if you don't have a main sewer system, like in a larger populated area, you would have either one of two things, a cesspool or a septic tank. A cesspool is more on the lines of like industrial buildings or something like that are too remote for like a sewer system, or they produce too much waste to be dumping in the sewer. So they use what's called a cesspool. And so a septic tank and a cesspool are very similar. So let's just look at each of these. In a typical home, you're going to have like an outlet, right? It's usually a large, here in this case, in this drawing, we have what, a 4-inch pipe probably coming out of the house. And it usually has a bidirectional or a unidirectional clean out. A clean out is an angled access to that pipe in case it gets clogged, right? And if it's going to get clogged, it's going to get clogged, you know, at a junction or something. So it's angled so you can put something down there to push it in one way. But if it gets clogged up at the house, you also should have, it's not drawn here, but another access point, and it could be in the same place, and it's usually a bifurcated pipe or whatever. But anyway, you would have it to where you could access it going towards the house as well. Okay, and then it usually opens up into a larger county or city-owned pipe, and that's usually a 6-inch concrete or clay, or, you know, they used to use cast iron. Terracotta is the clay. Anyway, then it opens up to the main line, right? That's usually down the, you know, along roads, right? So you see the manhole covers, right? Those are access points to the sewer in case, you know, something breaks, or, you know, a big heavy truck can crush they're usually made out of concrete and stuff. So concrete's great because it doesn't corrode like a metal would, and it's fairly cheap to make large amounts of it. So that's kind of how it goes, right? Most of the time, if you have some sort of problem in your house, you got to go find that outlet, right? The clean out. And sometimes that's not so easy. Okay, whether that line goes to past the clean out, if that line goes to a sewer, great. If it doesn't, you have to use either a septic tank, which is shown here, which is kind of like its own little sewer system. And so it's a tank, basically, that allows the waste to settle, to separate, right? The heavier stuff falls down to the bottom, becomes sludge because of microbes that will eat it away and break it down. So it breaks down all those proteins, and so enzymes are what are used. And so if you own a septic tank, every once in a while, they suggest you flush some enzymes down there so that it helps eat that stuff up, breaks it down. And then you have the floaties at the top, like fatty things like grease and things like that. So you don't, when you own a septic tank, well, you really shouldn't put like fats and stuff like oils and grease down the drain. Clogs up your drain for one, but it also can end a septic tank's life, or it needs to be pumped out more often if the scum gets too high, gets too thick. But the basic stuff, right, the water stuff suspended in the water actually settles between the scum and the sludge. That sounds great. But anyway, and then it drains out to a drain field. And so you have your drain field out here. Drain field comes out of the septic tank, and then it goes into a distribution box where multiple pipes are attached to it so it can drain out. And then you have these perforated, usually clay or plastic, PVC, polyvinyl chloride, I guess, right? Or ABS pipe that are perforated, so it allows the the water to leach out into, just kind of seep out into the ground. And then the ground acts as a great natural filter. So all you got to do when you have a septic tank is just make sure you're not too close to a river where the ground doesn't have enough distance to filter out the viruses and the bacteria and the other stuff that does get suspended in your wastewater. So the wastewater stuff comes in from your house, and the stuff that sinks goes to the bottom, the stuff that floats, it comes out of here and then it floats up. So that's where your problem's going to happen if there's too much sludge and it gets up to your baffle, or there's too much scum and it gets up to the top and then it has no room. So, and it clogs up your outgo, your effluent, right? The stuff that goes away. It's remarkable how little distance it actually needs from a leach field, right, to be clean, to where that water, the actual water, can get in, and it has no, it's not a biohazard or anything. So does that make sense how it kind of works? Is that all right? Okay. A cesspool is kind of like a leach field and a septic system all in one, right? So it has a semi-permeable boundary to it, right? And then, so the inlet just comes in, and the gunk, the sludge, sinks to the bottom, and the scum floats to the top, and the stuff that's suspended in the water can leach through the walls of the cesspool into the ground and float away, or just drain away. And then, it has to have a healthy ecosystem of the enzymes breaking down the sludge, and then just not too much scum at the top. Usually these are open pit kind of things, a cesspool, and it's kind of stinky. So, but you won't see those at like residential houses, really. Anyway. Here's a couple other slides for reference purposes. Well, this one's for reference purposes. As far as driveways go, there's some codes. There's some kind of minimum standards going on, so for different configurations of driveways. And so that's concrete work and whatnot. So the main idea is so that you can safely enter and exit a property, right? So there's some minimums. I'm not going to go over them all, but you have a 2-car garage. You have some. These are mostly minimums, right? And so they can go from there. So for 2-car garage, a nice turnout is safe. That's actually kind of desirable because you can exit into the main street from your residence, going forward, not backing up. So that's helpful for pedestrians as well as bicyclists and children and things like that. So. You also have side garages where the garage doesn't face the street. All kinds of, the U-shaped driveway is nice also, but for only 1 car. Okay. Anyway, those are driveways. Now, as far as drawing property lines and things like that, when you get to curves, some of the data, this would be how you would dimension a curve. This data would actually be listed on the curve itself or in a table. So length, radius, delta is the central angle, if you will, of the curve, and the degree of curve we'll talk about later also. I'll just mention it real quick and then we'll get into it, like how to actually figure that. That's the amount of angle that's required for 100 feet, right? One whole station value of length of the curve, right? So the length of the curve going around, if this was 100 feet right here, then this would be the degree, the angle that what do you call that, subtends 100 feet. And that's a D. Okay. As far as drawing out property lines also, we also need to figure the drawing size, right? What's the output? Draw the boundaries, get the proposed structures in there, their dimensions, and label the boundaries, the directions and distances, and the other marginalia, your name, the north arrow, coordinate system if needed, and such. Okay, that is it. So we're going to do an example together. What are we going to do? Let's do problem 9-2. Yeah, this has a curve in it. That'll be nice. Okay. So we zoom all after we set our limits. 0, 0, right? So limits, and then just hit space twice, basically. Limits, space, space, and then 1200, comma 900, space. That's it. And then zoom A, right? Z, space, A space, and then I'm ready to draw. So I'll draw somewhere down here, and I don't think, I'm going to hit F12 just to turn off the dynamic input, because sometimes that messes me up. Let's just see how this works. So actually, we'll see if it works with it on it. Just to, okay, so ignoring what the dynamic input says, it used to screw you up, but I don't think it does anymore. I'm going to type in 166 and then a less than symbol, right? I don't know if that worked. Hold on. It seemed like it. Okay, first point, just click. Second point, 166 less than, there we go. I must hit the wrong number. Okay. And then we go north, actually, yeah, north 14 D for degrees. It recognizes that D for degrees and 6 minutes, 17 seconds. So 6, single quote, 17 shift quotes, double quotes, right? For seconds, and then W for west. Yeah, so that's a shift comma, right? And then again, go 97.25. So you should see this. After you type in your 166 and then less than, right, which is the shift comma, then you should be able to type in. Oh. No, I think that's okay. So wait. It looks like this. That shouldn't do anything. So if you have your dynamic input turned off, you're just going to be typing in your command line, right? Nothing, you won't see it on the screen, just at your command line, which is fine too. Yeah. Yep, north 14D, 6 tick, single quote, right? 17 double quote, W.
166 less than D 14 D 16 tick 17 double tick. That typing is the enter.
Yeah. Yeah. Say what? Okay. So let's go over this. Let's go over it again. So I'm just going to start over here. Okay. The dynamic input does make a difference. I was thinking, I was just kind of toying with it while you're doing that. It does. So this is what it, so with it on, this is what you have to do. It's actually simpler when it's on. So I'm going to leave it on. And so I'm going to just type in the distance, like 166, and then less than. But don't move your cursor after that because it won't work after that. So 166 less than, and then I'm going to go north 14D 6 tick 17 double quotes W, and then enter or spacebar. And then it draws it, right? So now I just go immediately to 97.25 less than, right? And so it should show up like this, where you see the little red angle. That less than indicates an angle. Does that work? Yeah, F12 turns that on and off. So make sure that's on, or else you have to, if you don't have it on, you have to type in that at to mean relative coordinates. Otherwise, it just goes off the paper or whatever. It just does its own thing. So yep. So you type in the distance first. So 97.25 less than, and then N 86 D 29 tick 58 shift tick E. Enter. Okay, so drawing the arc, now that we have those 2 points, it's actually kind of nice. So I'm just going to draw an arc, A space, Now arcs, AutoCAD likes to draw arcs counterclockwise. So I'm going to start this point, and then I'm going to pick this as the end point, but it's wanting the second point. So I'm going to choose end, E, space, right? And click on the end. And then I can just specify like I don't know where the center is, although I kind of do, right? So if, well, I don't. But I do know the radius, right? So maybe I can just hit R for radius and then just type it in. In this case, the radius is 130. So there, done. Got it drawn. Now we're going to label them. It's pretty much easy to label these, but I'm going to talk about the art first as far as its label goes. So let's go to dimension layer, I guess. Did we have one for our annotation layer? C anno or something? There it is. This is where I'd put those. Anyway, let's put and then my text style. So under annotate, I'm going to change my style to civil. And it's a 10th inch text, so that's nice. However, this before I start annotating it, I think I need to set the scale, right? So now that I have the property, lines drawn, right? Then we can print it. We can pretend to print it and figure out the scale, right? That makes sense, what we're doing? So yeah, I'm gonna go Control P. We'll pick a nice printer, like our DWG to PDF, and then choose our full bleed ANSI A. I think portrait would work in this case. We'll go portrait. Display, we'll do extents, center it, uncheck fit to paper. 1 to 15, well, I can't go 1 to 10, right? So, and these are feet, right? So 1 inch is 10 units, that's 10 feet, so I have to go to 20. So let's look at that. That looks actually pretty good. So I think I know what my scale is because it fits.
1 to 20?
Yeah, I think that does, right? Do you see how I chose 1 to 20 though?
Yeah.
Because fit to paper looks like this, which wouldn't be appropriate anyway. So I have to go smaller than that. I have to, you know, something other than 15.18. The next number, I can't go 16, right? 1 foot is 16, 1 inch is 16 feet. Doesn't work. So 20. I can read that on a scale, right? So that's why. So that's gonna look like this. Looks great. So I'll set. Yeah, I'm gonna click OK on that. So I actually added this to some named setups there, so I can go back to it. So I don't have to do this again. So cancel it. Then I need to choose it from this list, right? So somewhere in there, what you got an error or a warning, right? Saying that you have some text. Do you have some text in your drawing already? When you preview it, it fits though, right? Looks like we're good. So I'm going to set my annotation scale over here to 1 to 20. Even though AutoCAD thinks that's 1 to 20 inches, basically, it's not 1 to 240, which would be the actual reference scale of a 1 inch is 20 feet kind of drawing. Yeah, that won't matter because we're not going to use layout, but that's fine. Okay, now I can put some text in here because it's annotative and I got my scale correct. So I'm just going to go T and we'll put a text box here. And I'm just going to type it in the way we see it. L equals, what, 57.27 feet. R equals 130 feet. Delta. Oh, what's the command for delta? Well, I don't really know, but I think I can go to symbol. Is there a delta in there? Yeah, 0394. So if you don't want to do it this way, you can type in an alt 0394. It should work. Let's see. Alt 0394. That does not work. Huh. Okay, fine. Forget it then. Just never mind. There's my delta. And 25% D, 14 tick, 24 shift tick. And that's actually the central angle, right? So if I yeah, there you go. So if I actually drew lines from the center to the end there, sometimes these lines would be a radial line. That means they point to the center. Sometimes you'll see that, but these aren't, it doesn't look like. So if I measure, though, the angle in here, 24, yeah, 25.24, which probably adds up to 25 degrees, 14 minutes, and 24 seconds, or near that. So anyway, don't need those lines, but. Okay, bearings and distances, and then put a border on it, and you're done, right? Okay, great. Oh, yeah, not quite done, but we'll get there. Let's put another text box. Yeah, that guy here. This text does look a little small, but should be fine.
All right, south and west on that last one. Zero. One.
I'm sorry, what?
I don't know. Draw that line. South and west.
Yeah,
So you just use the one that's book north 5.2 seconds.
yeah,
East.
yeah,
Use that east.
yeah. Type in, right. Um, All right, I guess it's time to talk about, well, we got it pretty much all figured out, right? So we're going to add a border. We do need to make it portrait. I think it'll fit. Let's see. See right here. I have my dynamic border for some reason, so I'll just have to OK and rotate this guy here. Move it. Well, it's pretty close. Yeah, close enough. Could save some room here by moving that. Moving this guy. Yeah, fits just nicely. Okay, I also want to put in the legal description. So that's just going to be another text box here. So text, and just make a nice text box here. So we're not going to put in any of the fancy words. We're just going to go starting at south. What is it? The southwest corner. Westerly corner of lot. Thence. I'm just going to go with thence. New sentence. Thence north. 14 degrees. Six minutes. 17 seconds. West. Yeah, I don't think I need to type out the north actually. There we go. Makes it good. For a distance, the first time I might use for a distance of kind of thing, 166.00 feet. Okay. Thence Six degrees, 29 minutes, 58 seconds. East. For 95.25 feet. Sometimes that foot's spelled out, but I'm just being abbreviating here. Thence. So one way to do this to make sure that it kind of jived with what the labels that we had, you would mention, I'm not going to do it here, but another way to mention this would be to starting at, maybe I would say southwest corner of lot being the, being at start of southerly arc, I guess, most southerly arc of lot, thence north for a distance of blah blah blah, and thence. So down when I got to this part, I might say thence, yeah, from continue, continuing, continuing, thank you, to southeasterly end of said arc, southerly arc. Right, so that describes that we're at the other end of that arc, bearing to said point. I can type. To said point north, and this is where I would type in the north, 0 degrees, 5 minutes, 6 seconds east, 160 feet, or maybe I'd put to said point after here, bearing this to said point. That way, it's kind of backwards speaking, but that's what's happening, right? And that's why we have this north instead of southeast. Southwest, you have this northeast bearing. So you might see wording like this. That's often that way. So I think it's kind of confusing, but that's how that works. All right. Another way to put that, let's see, the corner of lot being at the start of southern border of something like that. I guess that sounds a little better, I guess. Starting at the southwesterly corner of lot being at start of arc being the southern border, most southern border of lot, thence blah, 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 to end of southerly arc, bearing to said point. Of arc, and this is where I would describe the arc, having a radius of, how about a length first, right? Length of whatever it says, 57.27 feet, and a radius of 130 feet. Through a central angle of, right? (25°), 14 minutes, 24 seconds. There we go.
57.
So there's our nice legal description. Does that make sense? Kind of how that's written, though. I mean, it's just thence just means going from one point to one point.
57.27 units, and the radius of 130 is central.
57.27 feet
Oh,
with a radius of 100. Yeah, I put width. There we go. All right, that'll do it. That's all right. At this point, that's pretty much done. So the next assignment will be problem 9.5 on page 306, and we'll make that as kind of an independent one. So we did this one together, and that's great. 9.5, you guys do, and we can talk about it and stuff, but go ahead and try that one completely on your own, doing just what we did here, drawing the property and constructing the legal description from it, labeling it. This one actually has a lot. The other thing we should do is figure the area, right? How many acres we have here. So how do you do that? Well, I know of one way. If we convert this boundary to a polyline, right? So just join them, J space. And then I pick my polyline and go to my properties, it'll tell you the area, right? And that's in feet. That's in square feet because we drew it as in feet. So there you go. But we want it in acres, right? So what do we got? How many acres is that? Well, I can take that number and copy it once I go to the calculator with it, close that. I don't really know. In fact, I don't want to change that number. But let's see. Square, if I could type, I could really do something. Square feet to acres. There you go. So I'm going to paste in this number of square feet, and there's my acreage. Copy that number, go back to AutoCAD, and we'll label acres, right? So this is lot something or other, lot 300. So I need a nice little text here for that. Lot 300 and paste. Maybe I don't need to take it out to that many acres, but I don't really care. There we go. And I'm going to make this a little bigger too, maybe 0.2, like title type of text. There. There we go. By how much?
1, 2, 3, 6, 3 area. That is 1, 2, 3, something. 2, 4.
Oh yeah. I could be wrong. I definitely could be wrong. Say what?
Use my answer.
Yeah, go ahead and use yours. What I would do is just check my, well, I'd explode this back to lines and then just pick the, the length. I'd just check the length and the bearings of each of my lines. So it looks like that one's okay, right? 6, 14, 6, 17. Yeah. 97.25, 86, 29, 58. It looks good. 160 at 5 degrees, 2 minutes, southwest. I don't know what it can tell me about the arc here. Let's see if I can. At total angle, 64 degree. Now, that's the other direction, so we don't care about that. Arc length, 57.27. That is correct. And the radius, it's 130. Yeah, if I add these two up, you know, the start angle, basically if I drew those two lines from the center, the start angle would be north 5 degrees, 36 minutes, 33 seconds east. And the end angle, that would be to the right. And then going left, because it draws left, 19. So if I add those up, I get 24. I get 25 degrees, and then 36 plus 37 is 1 degree. So that's 25. And what is that, 73? So that'd be 13 degrees. So 25 degrees, 13 minutes, and 84 seconds. So that's 24 seconds and another dealio there, which is exactly what we had here. 14, that 14 goes up to 13 and 24. So yeah, I drew it right. There you go.